So today we will discuss about some important points about the order of reaction. Okay, the first point which I told you in my first video as well, that the stoichiometric coefficients have nothing to do with order of with nothing to do with order. Like for example, we have a reaction which is 2N2O5 and it decomposes into 4NO2 plus O2. So the order of reaction will be, if we talk about rate of reaction, that will be K N2O5 1. So stoichiometric values have nothing to do with the order of reaction. The order of reaction is simply an experimental value which you have to do. In order to find the order of reaction, you have to do the experiment, right? It is a experimental value. Experimental, right? Now second thing is, in rate law, concentration terms of products may be present. Like sometimes, like one in in 10,000 there will be one reaction in which product also, like rate of reaction also dependent upon the product. For example, let's take the example which is the formation of ozone. Okay, 2O3 forms 3 oxygen, right? So here for this the rate of reaction will be ROR is equal to K O3 2 and O2 minus 1. So as you can see over here, this is the product. So in some reaction, like in a very rare cases, like 1 in 1,000, right, this product is also involved in the rate of reaction, but not in most of the reaction. Generally we only say that the rate law is basically it explains as a dependence of the concentration of a species in a reaction, right? That's why we wrote the word species. Like if we talk about my previous video, I told you guys that it explains us the dependence of the concentration of a species. I didn't wrote in my previous video I wrote reactant, but after that I wrote species. What does that mean, species? Means sometimes products can be involved in the rate of reaction, right? But in a very rare cases. Now third is, in rate law, concentration terms of some reactants may be absent, right? Okay, for example, like I'm saying that, for example, there are two reactants and one of the reactor is missing, like we are not counting that. For example, we have formation of, like where NO2 plus oxygen, it forms NO plus carbon dioxide, right? This is a reaction. In this, what will happen if we talk about the rate of reaction, that is equal to K NO2, the constant here 2, and O2 is equal to 0. Sorry, I wrote the reaction wrong. It is basically CO and here CO. As you can see over here, it is 0. So we can write that ROR is equal to K, which is NO2 2, right? So as you can see in this rate of reaction, we didn't include the carbon monoxide. We didn't include. It means that in some reactions, like in rate law, concentration terms of some reactants may be absent. right? Let's discuss about the fourth and the last point, which is in rate law, concentration terms of catalyst may be present. Concentration in terms of catalyst may be present. For example, 2SO2, we have sulfur dioxide and it decomposes into, if it is sulfur dioxide plus oxygen and 2SO3, and the catalyst used over here is NO. Right, if we talk about the rate of reaction, it will be KO22 and the concentration of NO1. So as you can see over here in this rate law, the concentration of the NO, which is the catalyst, also being utilized, right? So in some reactions, so it means, like, if we conclude from the important points, that stoichiometric coefficients have no value. In rate law, you can the rate of law can also depend upon the products, and sometimes we may skip a reactant, and sometimes, like in very rare cases, the catalyst may also get involved in the rate of reaction, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comments.